Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. This video, I will show you the final part modeling of my SolidWorks Make Frother project, which is the cap here. So this cap is kind of like fitted, like snap fit onto this opening of this bottom casing. Since this is the 3D rendered image that I've done, I kind of like off the top casing. Okay, if I show you another view here, okay, this is another view. Okay, here this is the plastic cap. Okay, this plastic cap is kind of like fitted onto the volume of this bottom casing and also the top casing that I have not shown here. Alright. Alright, the material of this cap here is kind of like a soft plastic. It kind of like it could be a soft plastic material like a silicone or others, or maybe it could be a rubber. Alright, at the beginning when I thought I want to do this part modeling of this cap here, I thought the easiest way is for me just to do revolve by creating the profile, and I simply do revolve and it can make the shape of the cap. But I found out that since the volume of this bottom casing, because when I made this modeling of my bottom casing and top casing by lofting, because the either between the left side and the right side of this bottom casing and top casing is non-symmetrical. So if I do revolve, it means the result of this cap is kind of it will intersect, kind of overlap with the edges of this bottom casing. So what I need to do, I have to make a shape. It's kind of like it fill in the volume inside the region here, but at the other region out there, I can make simply like a dome shape. All right. Okay. To do this in SolidWorks, okay, let me show you in new part file. When you go to new part modeling file, so in this modeling of this cap, I will not go in assembly mode. I just simply go for new part modeling file. Right. Okay, sometimes when you do part modeling in SolidWorks, okay, when you open a new part modeling file, you can also insert the other component that you have done. For example, I've already done bottom casing and top casing. Okay, the idea of me to insert this bottom casing and top casing in this new part modeling is that I can know the volume here inside the where I can do part modeling of this cap. Okay, the idea of me, I can do intersect. When I do intersect in SolidWorks, I can know the region of this volume. The output of the intersect, it can provide me the shape, the region inside there. That it kind of like fill in the volume of the bottom casing and top casing. Okay, let me show you in SolidWorks. Okay, now this is a new part modeling file. Let me show unit is MMGS. Alright, here under new part modeling, I can insert here under the menu we have insert. I can insert the part. Okay, now I will browse here. Since in my previous video, I have already shown you how I create separate part file. So all I have here, all my separate part file here is listed here: bottom casing, opening lid, push button, steering rod, tactile switch, and also top casing. In this case, I will insert the bottom casing first. I insert the bottom casing. Okay, now my bottom casing is appear on the screen, but I not clicking on the screen. I just simply click OK here. So it means my bottom casing is already inserted in my screen here at the origin point. It's kind of like it is a base component, right? Okay, now I will go insert another part. So the next part will be the top casing. So I click open. Now my top casing is here. So I simply pick it anywhere above here. Alright, so my top casing is already placed in that position. Okay, what I need to do, I need to do kind of like in assembly mode, I do mate setting to put into the exact location. Right, since this is part modeling, it's not assembly mode, I don't have here the mate setting, but I can do that by using move body copy command in SolidWorks. Okay, to do that in SolidWorks, here in the menu under insert here, we have features, move copy. Okay, in my previous video, I kind of like have shown you how we do. For example, the setting is like this: body to move copy when we do cloning our parts. Okay, sometimes your interface is showing like this, but I need the setting is not like this. I can go to constraint here. So this is the setting that I want. All right. What I want to do is I want to move this top casing into the exact position. Okay, here the interface body to move is this top casing. Okay, under the mate setting here, similar like what I have shown you in assembly mode when I do the mate setting to put the parts in exact location. Similar approach, the mate setting here, so I can put this top casing into the right position by setting the first mate setting here. This space, if I zoom in, this space would be touching this space. So SolidWorks already set it is in line in coincidence, so I must click at the add. So whatever setting here is listed under listing here mates. Okay, my second setting will be I want my here I have a circular edge here. I select that circular edge and also this circular edge. Automatically SolidWorks will put it into concentric. It means it share the same center point there. So I must click add. So I have the second setting. My third setting will be this space, and this space will be in line. So I click add and I click OK. Then now my top casing is in position. Okay, since I have put this bottom casing and top casing into position, okay, the idea of me putting this bottom casing and top casing in this new part modeling file is that I would create I can know the internal region by doing intersect. Okay, let me show you why I do this. Okay, here, if you look on the top plane here, is at the middle here. So I will create a sketch on that top plane. So if I go to the normal view, all right, the idea of me doing this is that I will create any profile here, a closed shape to do revolve, and I will make it as a separate body. By doing intersect, the shape of the revolve intersect with the top casing and the bottom casing, I can know the internal region based on the output of that intersect. So that internal region created will be my starting point to do add another part modeling for the cat. So that's how I do it. All right. Okay, since I'm this sketch mode on this top plane, so I will create, okay, since we have already have the origin point here, so I can create a rectangle as long as bigger than the half width of this bottom casing. Okay, I just put some dimension here. Okay, I can go for this one, I go for 8, right, as long as longer than the half width of this top casing, and but here the height I want it to be 4. Okay, 4 millimeter for the height. So that will be the internal volume, the internal region, the thickness of the internal region of my cap. Okay, I have this profile here, so I can do under the features, I can do revolve. All right, so the axis of revolution will be this edge. Hold on. So, okay, this is very important. I make it a full revolution, but here I do not check at merge result. I uncheck it because I want to make it as a separate body. Okay, now I have this revolve object here, and it is a separate body. If you look here, we have 3 solid bodies: bottom casing, top casing, and also revolve. Okay, the idea of me is to do intersect. By the output of that intersect, I can produce the internal region of these 3 components: bottom casing, top casing, and this revolve. Okay, let me show you. Okay, since I have these 3 components, okay, we have intersect here. I've kind of like already explained to you intersect in my previous video. Under insert, we have under features here, we have intersect. Okay, when I do intersect, okay, let me clear the listing here. Okay, I will select the top casing, bottom casing, and this revolve object. Okay, then I click that intersect. Okay, here the setting, I go for create both. Then here I click intersect. hold on, SolidWorks is doing the calculation. Okay, now here the listing of the the region list. Okay, I would check which region that I want. Okay, for example, I check a region 1, the output is like that. I check a region 2, the output is like that. I check a region 3. Okay, if I check the region 3, it will be like that. Okay, let me check at region 3. I check at region 4. Okay, but region 4, I will uncheck it. I want the internal volume. Region 5, I check it will be like that. And region 6, I check it will be like that. As you can see here, by unchecking the region 4, the only region 4 that I uncheck, so this is the volume that I want to do my plastic cap. Okay, I just click OK. So this will be the output that I want. So this output will be the starting point for me to do the plastic cap, right? Okay, since if you look here, the bottom casing and top casing is already not shown because it is based on the output of the intersect, right? Okay, let me save my file first. I go file save as, be sure it is in new folder too, and I name it as plastic cap. Actually, it's soft plastic, but I name it as plastic cap. Okay, I have done this before. I just replace it. Okay, then I already saved my part file by the name of plastic cap. All right, let me show you in the feature manager here. If I scroll back here up until position body move copy where I have the top casing and bottom casing, I need to check what is the the diameter of this curve. I can go to under evaluate here, so I can do measure, so I can select this curve. I need to know what is the radius. So its stated radius is 5, so it means the diameter of the circle is 10. Alright, so that I go back to intersect. Okay, since here this region is the internal part of my plastic cap in the bottom casing and top casing, I will create the exterior region on the left here. Alright, so here since I have a flat plane here, so I can create a sketch. So I will create a circle at that center point, then I create a circle by the diameter of 10. Okay, diameter of 10. Okay, the idea of me doing this, I would extrude it just by small amount, about 0.1. Right, so I click OK. So since I have this really thin cylinder here, so I can select this face, then I will insert features, I will do dome. Alright. Okay, the dome you can go for any value, but I don't want it too much like this. So I will go for about the size of 4. Because I think 4 is the kind like the shape is good enough for me to create this exterior region of this cap. Let me click OK. So this will be the basic shape of my plastic cap. Okay, here under if you look in this image again, okay, if you look here, this plastic cap, I need to create a cut through hole since as shown here, we have the steering rod pass through this plastic cap. The diameter of the steering rod is 1.5, so it means that I have to create a cut through holes by the diameter of 2, so it will kind of have a tolerance for this rod to pass through, right? So here I have a flat surface here, I would create a sketch on that face at a center point, so I will give a diameter of 2. Then I will do extruded cut through all. Okay, so then I have a hole there. So I have kind of a tolerance since the diameter of this hole is 2, right? So let me save my file first. Okay, another thing to mention is that if you look in this image, okay, this plastic cap have the hollow properties here. It means I cannot make this plastic cap solid like this. Even this plastic cap have a soft material. I need to add features like shell to make it hollow to make the plastic cap more flexible. Okay, as shown in this image. So I need to do this by doing shell. Okay, under the features here, I put shell. Then I put the thickness of the shell. I go for 1. Then I click at the surface. Then I click OK. So I have a shell features for this plastic cap. If I go for section view, so we have a shell features. It's much better to have these features shelling, so it make this plastic cap more flexible and easy to squeeze in. Alright, so let me save my file again. Okay, the next thing to do, if I open my assembly file. Okay, by the way, I just need to mention to you, this assembly file that I've created earlier is just a temporary assembly file. Later in my next video, I will show you how I will do full assembly for this frother. Alright, this is assembly file. I'm now in assembly mode. I need to insert that plastic cap that I have just created. Okay, so I insert the plastic cap here. I put somewhere here. Okay, for this main casing file, let me off the top casing. Alright, I will do mate setting. Okay, since here, for this plastic cap, I have a cylindrical surface inside there. So it will mesh with the cylindrical surface of the shaft of the motor. I click OK. Now it is in position in terms of concentric. Then I will go this space, will touch this space. Okay, now I have my plastic cap in position. Let me click OK. Then let me on back my top casing. Alright, nice. I think the plastic cap, if I do the dome value of 4 is kind good enough. It's kind like the shape of this plastic cap blend with this top casing and bottom casing. Alright, Alhamdulillah, I have completed my part modeling of my plastic cap for my SolidWorks frother project. Okay, inshallah, in the next video I will show you how I will do full assembly of this frother project. Inshallah, I will see you in the next video, but before that, please do not forget to click subscribe and like my channel. Assalamualaikum warahmatullahi wabarakatuh.